Okay, Kate, you guessed that n equals to 10. Okay, if n equals to 10, right? Okay, let's say n equals to 10. So then you have 10 divided by 15 plus 10 divided by 20. Will this give you a whole number?
No.
Will this give you a whole number? No,
Yeah.
no, it won't. 10 over 20 is half. It's not a whole number. So you will not end up getting a whole number. So I don't think you can say this. Why not I try this?
5.
No, let's try this. What is 60 divided by 15?
60 divided by 15 is 4.
60 divided by 20?
60 divided by 20 is 3.
Does this give you a whole number?
Yes.
Very good. Why do you think the number 60 actually worked?
Because it's multiples of both 15 and 20.
Very good. It is a multiple of 15 and 20. In fact, we can just call it the lowest common multiple, correct?
Mhm.
Lowest common multiple of 15 and 20 equals to 60. So if we actually make use of the lowest common multiple, then it is very easy for us to get whole numbers, okay? So let's write down all the multiples of 60. You have 60, 120. Okay, let me give more space. 60, 120, 180. Do you agree that all these numbers, okay, if let's say you divide by, okay, if you have 120 divided by 15 plus 120 divided by 20, tell me, will you get a whole number answer?
Mm?
120 divided by 15 is 8.
Yeah.
120 divided by 20, what do you get?
6.
Do you think you get a whole number?
Any multiple is 60.
Yes, any multiple of 60 is going to give you a whole number because that's the lowest common multiple, okay? So we continue writing down all the multiples of 60. Then we have should I continue or not, Kate?
Mm, I don't think 960 works.
Should I continue?
No.
Why?
Because it says less than 900, so 960 and 900 both don't work.
Correct. So then how many values of n, how many possible values can I have?
14.
Okay, if you count them, you have over here we have 14, right? So
14.
I'm going to say this. Can anybody guess? And Kate, can you guess? Why did I do this?
Because
If anybody want to try, you can raise your hand. Why did I plus 1? But there's 14 here, right? So why did I plus 1? What is the extra value of n that we did not think about?
the x
Anybody knows? Nobody knows.
0.
Very good, Kate. Excellent. X can be 0, n can be 0 as well. 0 divided by this plus 0 divided by this gives you 0, and 0 is considered a whole number. Very good. Well done, Kate. Good job. Okay, anyone have any questions? Must raise your hand, okay? All right, students. So you make use of lowest common multiple here. Now let's take a look at the next one. Okay, for this, we need to revise what is average. Now, some of you may know average equals to the total divided by the number of people. For example, if I have 3 students and this guy has 6 sweets, 8 sweets, and 10 sweets, then the total number of sweets is 6 plus 8 plus 10 divided by the number of people, right? So you're going to get the answer of 8. But I do not want you to use this. Okay. Now, I'm not saying that this is wrong. I just want to let's try to use another concept here. I would like everybody to use the concept of fairness. So let me ask Ethan. Okay, come, let's talk about fairness. Ethan, I have 3 students here. They have 6, 8, and 10 sweets. Now, my first question to you is it fair that they are having a different number of sweets? Not fair. How do I make it fair? Person C must give
You-
how?
2.
Yes, you give 2, then everybody will have how many sweets?
8.
So what's the average?
8.
8. Students, do you see how fast that is? Did I need to go and calculate so much? Do I need to do like that? This plus this plus this, divide by 3 equals to this, divide by 3 equals to this. I don't have to do this. It's so fast, students. You use the concept of fairness. Is it fair? Not fair. You give, you make sure everybody have the same amount of sweets. Immediately you get the average. So fast. So fast. Okay. Now let's think of another scenario. Let's say you have this guy, and this guy. Okay, let's say, wait, I have a question from Joel. Yes, Joel.
I think I got another method for question 2.
Oh, the previous question, is it?
Yeah.
Okay, you quickly share what's your method.
So I think we should 900 divided by 60.
Yes, very fast. 900 divided by 60, and you immediately get the answer of what?
15.
Well done, Joel. That is even faster. But the reason why I wrote all this down is to visualize the question, okay? Now, well done, Joel. And your 15 also includes a 0, right?
Yeah.
Good. Okay, students, learn from Joel. If you already know how to visualize, you don't have to write it down. Just take 900 divided by 50, you get everything. Now, usually when you take 900 divided by 50, you have to minus 1 because you are including the 0 as well. But in this case, if you want to include the 0, then you don't need to minus 1. You straight away get the answer 15. I mean, in different situations, you need to minus 1. Sometimes you don't need to minus 1. But thanks for sharing, Joel. That was a very fast method. So back to average. Just now we talked about fairness. Now let me think of another situation, Ethan. Let's say now everybody has 5 sweets. Is it fair or not? What's the average?
5.
Very good. You don't even need to calculate anything. The average is 5. But now, I'm going to tell you this. Okay, there's student A, student B, student C. Everybody have 5 sweets. Then another guy called student D. He come in with another bag of sweets. Okay, he's carrying a bag of sweets. Okay, so let's say he's carrying a bag like Santa Claus, a bag of sweets. Okay, let's say he has, let me think, 13 sweets inside this bag. So he comes and join everybody with 13 sweets. Now you tell me, is it fair? No. What must he do to make it fair? What must he do to make it fair? How many sweets must he give his classmates? If you know, you can type in the chat also. If the rest of you want to answer, you can answer also. Yes, Reagan, Kevin, Zeyi. Yeah. Ethan, you just need to give 2 sweets to each person, right? Ethan, okay, give 2, give 2, give 2. How many will everybody have now?
7.
Yeah, 7, 7, 7. How about person D?
7.
Yeah, because 13 minus 6 still gives you 7. So what's the average now?
7.
Yes. Do you notice that when person D come in, then suddenly the average became higher. It became 7, yes? Okay, so he gave six sweets to everybody else. Did he keep 7 for himself? Yeah, he have to keep 7 for himself. He cannot just give everything. Okay, if he give everything away, then it's not fair also. So let's take a look at this question. The average of 5 numbers is 76. So you have 5 numbers. 1, 2, 3, 4, 5. Is it fair?
Yeah.
What's the average?
76.
76. This is before. Now, what happened after that? After that, the last person joined in. After the one more number came in, okay, one extra number joined in. What is the new average? The average increased to what?
80.
80. So can you just imagine, everybody got more sweets, yes or no?
Yeah.
But there's one extra number, yes or no?
Yeah.
So before the extra number joined in, was there any extra number here?
No.
So let's just write 0. There's nothing here. Okay, at first there was nothing here. Then later on, it became 80. So let's take a look here. Each person got how many sweets?
4, 4, 4, 4, 4.
Yes, each person got 4 sweets. Who do you think is the person who gave them those 4 sweets?
6.
The last person, right?
Yeah.
This guy, this last person actually gave them all the sweets, right?
96, right?
And he kept how many for himself?
80.
Yes, he kept 80 sweets for himself. So if you want to find what is the value of the last number that was added, he kept 80 sweets for himself, and he also gave all these sweets to other people, correct?
Yeah.
How many of the other people are there?
5.
Very
100.
good. That means he started with how many sweets?
100.
Correct. Well done. Okay, Ethan, you got it. So students, you see, okay, if you want to make it clearer, you can just write 80 here. Then you just add up all together. You add everything together, you get the correct answer. So this person, the extra person, he came in with 100 sweets. Then everybody say, hey, give us some, right? So he gave some to everyone, but he kept 80 for himself. Understand? So he started off with 100 sweets. So this extra number that you added must be the number 100. Any questions, students? Raise your hand. All right. So this is called the concept of fairness. Always remember to ask yourself, is it fair? Okay. Then you can find the average very fast. Now let's look at number 4. This is a visualization question. Now don't read the question first. Ignore the question. I want to do my small experiment with you first. Zachary, come, let me ask you. How many people are standing in the line? How many people are standing in the queue here?
7.
Yeah, 7 people. Now let's just take a look at this guy. Okay, his name is Zach.
Yeah.
Okay, so Zachary, if I ask you from the front,
Yeah.
if you count from the front, which position is Zach?
3. 3.
Third. Can I say he's third?
Yeah.
If you count from the back, which
5th. 5th.
fifth? Very good. Then if I ask you, how many people are in the queue? Oh, very easy. 3 plus 5 lah. 3 plus 5. There's 8 people in the queue, yes or no?
No.
How many people are supposed to be in the queue?
7.
So what should I do? 8, then what? Minus?
1.
Why must I minus 1? Why do you think there was an extra person being counted? Who is this?
Um,
Who is this extra person that's being counted?
Zach.
Zach. Yes, because you actually count him 2 times, you know. You counted him 2 times because here is already including Zach. Then these 5 people is also including Zach. You counted him 2 times.
Yeah.
You must make sure to -1. Correct?
Okay.
Okay, so now let's look at the question. Now there's this guy. He is actually the 10th from the front and the 16th from the back. Now, can you tell me what is the total number? Okay, this is before. Let's write before and after. Okay, before. What is the total number of children in the queue?
25.
Yes, 10 plus 16, but you don't forget you must -1 because of Zach. Correct or not?
Yeah.
So you have 25 students at first. Now let's talk about after.
40.
The total number of children equals to, okay, let me just circle this. 5th from the front, 36 from the back. So 5th from the front, 36 from the back. But you must minus the extra person, Zach.
40.
40. So how many children were added?
15.
Very good. So easy, right? How do you find this question?
Easy.
Well done. Good job. Now, students, sometimes if the question give you big numbers, okay, 10 from the front, 16 from the back, then you're getting confused, front and back and front. What you should do, create a small experiment. Any kind of question, if it looks very complicated, just create a small experiment so that you can visualize what's happening. Okay? All right. Now, let's move on to the next one. Okay. Now, in a bag, there's 15 balls. And there are 5 different colors of balls. But each color has a unique number of balls. Okay, the unique. Okay, everybody, the meaning of unique, the meaning of unique is different. Okay, everybody is unique. Nobody is the same. Even though they are twins, they look alike, but they are not the same. The thumbprint is different. The dental record is different. Even the looks sometimes can be different between the twins, even though you're twins, right? So everybody is unique. That means when they're trying to say that the numbers, there's a unique number of balls. For example, there's 5 colors: red, blue, green, yellow, white. 5 colors. And the number of balls are unique. And there's 15 balls altogether. Okay, there's 15 altogether. Number of balls are unique. Can I say that there's 3 of each ball? Cannot. You cannot say that there's 3 of each color. Every color have a unique number of balls. So every number must be different, you know. Students, I give you 20 seconds. Can you think what are the five unique numbers? What are the unique numbers that can add up to 15? What are the 5 unique numbers that you add up to 15? Very good, Zhe Kate, Ethan, well done. 10 seconds left. What are 5 numbers that are unique, adding up to 15? Everyone think about it. Type it in the chat. Very good, Kevin. Very good, Reagan. Okay, Joel also got it. Okay, students. So we realize that the numbers are 1, 2, 3, 4, 5. 1 plus 2 plus 3 plus 4 plus 5 equals to 15. Correct or not, students? Okay, so let's just write it. Let's just move it to one side. Okay, we just imagine that you have 1, 2, 3, 4, 5. Now, okay, let's say you're trying to take your balls, red, blue, green, yellow, and white. 5 different balls, right? They say that what is the least number of balls that you must take without looking to make sure that you have 3 different color balls. Let me just give an example. Let's say you don't look. You cannot choose what color you're taking. And let's say I decided to take 3 balls. Okay? So if I'm very lucky, what will happen? Okay, let me ask. Let me ask Zicheng. Zicheng, the question want me to take how many balls?
3 different colored balls.
Yes, they want you to take 3 different colored balls. If I'm very lucky, I will straight away take 1, 2, 3. Are they different color?
Yes.
Correct. Atava, you have a question?
This is worst case scenario, right?
Correct, Atava. You are right. Well done. The worst case scenario. You must imagine what will happen in the worst case. That means if you are very, very unlucky, what will happen to you? So now I'm just doing the opposite. I'm just pretending that I'm super lucky. If I'm super lucky, I take 3 balls. I don't even need to choose the color. I close my eyes without looking. I'm so lucky. I got 3 different colors. I'm very happy because that's what the question wants. 3 different colors. But Zicheng, do you think everybody can be so lucky all the time?
No.
So the worst thing that can happen if you decided to take 3 balls, the worst thing that can happen, you take all the same color. 1, 2, 3. Uh-oh. Is this what the question wants?
No.
No. Okay. Sorry, there's only one red ball. Okay, let's use white. 1, 2, 3. Okay. So do I still need to continue taking or not, Zicheng? Do I have 3 of different
Yes.
color? I don't have 3 of different color, right? Kevin, well done, Kevin. So you continue taking, but then you're so unlucky, you continue taking the same color until there's no more white. Until there's no more white. Then you move on to which color next?
Yellow.
Okay, continue taking. Then now you have 2 different color. You have 2 different color, right?
Yes.
Then would you like to take a different color now?
Yes.
You would love to take this, right?
Yes.
Are you so lucky?
No.
So you continue taking yellow. Very unlucky. Until all the yellow is gone. Now you only got 2 different colors, right?
Yeah.
Must you continue taking? Must you continue taking?
Yes.
How many more?
1 more.
Very good. So altogether, how many balls you take?
10.
Well done. Does the last ball, does it matter which color is the last ball?
No.
So let's just take blue lah, right?
Yes.
And now you have at least 3 different colors. Very good, Zicheng. You got it. Well done. Yes, Atava, you raise your hand.
Did you receive my answer?
Atava, you got it correct. Very
Oh,
good.
okay.
Zachary, yes, you have a question?
Doesn't it say what's the least number? I mean, like it can be 3, it can be like 3 plus
can be
2
three.
plus 1.
It can be 3, right?
Yeah, it
So
can be like 3 plus 2 plus 1.
okay, let's take 3, okay? Okay, let's say you take 3 balls. Okay, let's say red, blue, green, yellow, white. Let's say you take 3 balls. 1, 2, 3. Do you have 3 different colors?
Yeah.
So is this what the question wants?
Yeah.
So you're done. You don't need to take anymore, right, Zachary?
Yeah.
Now let me ask you something. Are you allowed to choose the color that you take?
No.
You cannot look, right?
Yeah.
How do you know that you're going to get 1 red, 1 blue, 1 green? Can you guarantee or not?
No.
Are you so super lucky that you will just get that?
Maybe.
Okay, in mathematics, you don't want a maybe, right? You want to guarantee that you get 3 different color, right?
Yeah.
If you take 3 balls and all of them are the same color, like that, then how? Must you continue or not?
Yeah.
Of course, you need to continue lah. You need to continue taking. Then until there's no more white, then later you continue taking yellow.
Let's say it's the least number, so it can be 3, 2, 1.
Okay, let's say you decided.
Yeah, if you take green 3, B 2, and red 1 is the least number, right?
But you know what, Zachary?
Yeah.
Must always pretend that you are very unlucky. You're in the worst case scenario.
Okay.
Must prepare for the worst. What is the worst that can happen? Now, obviously, if you take 1 red, 2 blue, 3 green, then you have. Actually, you know what? You take 1 red, 2 blue, then do you need to take 3 green? You already have 2 colors here, right?
Yeah.
You just need to take any of the other colors. Just 1 will do. Correct or not, Zachary?
Yeah.
So you take 4, right?
Yeah.
So is 4 the least number that you can take?
Yeah.
Okay, let's take 4 lah. Now imagine you're super unlucky. I take 4. Are you ready? What
Huh?
happens? What if you get 1, 2, 3, 4?
Oh
Then-
yeah. Oh yeah. Yeah.
Then you still cannot make it, right?
Yeah.
So in order to guarantee that you have 3 color, you must pretend that the worst thing will happen to you. The worst thing is if you take all the white ball, then you take all the yellow ball, then finally you take any ball, any color. Then you will have 3 of the same 3 of different color, right?
Oh yeah.
So you must pretend the worst case scenario, okay, Zachary? Okay, very good. At least you clarify. Okay, well done. So let's take a look at the next one. Now, students, you have 3 different types of coins. Okay, let's find how many coins are there. Total number of coins. You have 15 20-cent coins, 7 50-cent coin, 8 $1 coins. That means there's 30 coins altogether. Now, you have 10 students. So how many coins does each child get? Okay, you distribute equally, equally. So you take the 30 coins, give them to 10 students. Each child get 3 coins. Each child will get 3 coins. Now, some of you may be lucky. Some of you may be unlucky. There are 3 types of coins here. First, you have the 20-cent coin. Then you have the 50-cent coin. And finally, you have the $1 coin. If you're very lucky, all your 3 coins, let me ask Jill. Jill, if you're very lucky, all your 3 coins is which one? 20 cent, 50 cent, or $1?
All the 3 coins will be $1.
Yes, $1. By the way, you understand why it is 3 coins, right? Do you know why everybody gets 3 coins?
Yes.
Because there's a total of how many?
There's a total of 3 coins.
The,
3 different types of coins.
no, I mean total how many coins?
Oh, the total is 30 coins.
And how many students are there?
10.
Yes. So that means everybody should get 3, right? Each person should have 3 coins, right?
Yes.
Okay, so if you're very lucky, all your coins is $1, then how much money do you have?
$3.
How many dollars?
$3.
$3, correct. But if you're very unlucky, then all your coins will be which coin?
50 cents.
Yes, and how much money will you have? You have 3 coins, right?
You have 60 cents.
60 cents. So what's the question asking? What is the difference between the...
Maximum and minimum
Yeah.
amount of money.
Do you think you know how to do it? Do you think?
Yeah.
Okay, everybody. Okay, Jill has already told us what will happen. Jill already told you what will happen if you're unlucky and if you're lucky. So you already know the maximum and the minimum. Can you tell me what's the difference? Everybody type your answer. What's the difference between the maximum and the minimum amount of money that anybody can get? Very good, Atava, Joel. Kate, very good. Zeyu, very good. Kevin, very good. Yeah, very easy, right? This question. I'll give you 20 more seconds. Those who haven't typed your answer, please type your answer. Ethan got it. Reagan got it. So just now, Jill already helped us to calculate the maximum amount of money. That means you have all the $1 coins. You have $3. But if you are very unlucky, then you will get the minimum amount of money and you will end up getting 60 cents. So what is the difference between $3 and 60 cents? The difference is $2.40. There you go. Very easy. All of you got it. Well done. All right, students, let's take a look at the next question. Oh, a palindromic number. So a palindromic number is a number that remains the same even if you read it from left to right or from right to left. For example, this number, no matter whether you read from left to right, right to left, is the same. For example, this number, you read it from left to right, right to left is the same. Everybody, can you give me another example of a 4-digit, give me a 4-digit palindrome number now. Everybody give me an example of a 4-digit palindrome number. Type it in the chat. 4 digits. Very good, Kate. Very good, Jill. Zeyu, yes. Ethan, yes. Well done. Let me write down some of the examples. Some of you wrote 1111, 5555, 1221, 6969. Wrong. Be careful. Be careful. This is not a palindrome. If you read it backwards, it becomes 9696. It's different. So if you want it to be the same, you can do this, okay? This is correct. Okay, students. So, these are some examples of palindrome. Okay? Now, what do they want? They want you to find how many palindrome numbers are there from 100 to 999. So, let's write it down. The number of palindromes. 1 digit, 2 digits, 3 digits. Can I ask Zeyu? Okay, Zeyu. Let's write down some 3-digit palindromes, okay? Or maybe 202212222, or maybe 303313323. All these are all palindrome, right, Zeyu? Zeyu. So Zeyu, if I want a number from 100 to 999, what is the first digit? Can my first digit be 1? Hey, Zeyu, are you there? Hi, Zeyu, where are you?
Yeah.
Can the first digit be 1,
Yes.
2, 3,
Yes.
all the way until which number?
9.
Correct. Okay. My first digit can be 1, 2, 3, 4, 5, 6, 7, 8, 9. How many options do I have to choose from?
9.
9 options. Okay, I can either choose the number 1, or I can choose the number 2, I can choose the number 3. I have 9 different numbers to choose from. Now, what about the second digit? You observe the pattern here. Second digit can be 0,
Yes.
can be 1,
Yes.
all the way until what? 0, 1, 2.
9.
Yeah, it can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many options do you have? You have 10 options, okay? Now, my last question, most important question. The last digit. How many options can I choose for the last digit? Can it be 1? Can it be 2? Can it be 3? What should how many options can I choose for the last digit, Zhe? What do you think? 9? Is it because it can be 1, it can be 2? Can it be 0 also? Can the last digit be 0 or not?
No.
No, because like, for example, like that, this is not a palindrome. This is also not a palindrome, right? Or 220. Oh no, this is not a palindrome. So Zhe, how many options do I have for the last digit?
9.
And I'm going to write down here that I have one option. One option, not 9. Why is it one option, Zhe? In order for it to be a palindrome, the last digit must be the same as the first digit. Correct. So if I already chose my first digit, okay, let's say I chose the number 5. Then how many options do I have for the last digit?
1.
Only one, and that will be the number 5. Very good, you understand. Well done. So you only have one option for the last digit, okay? Because the last digit must be exactly the same as the first digit. So you multiply all your options together. How many palindromes are there?
19.
Well done. So Zhe, how do you find this? Easy?
Easy.
All right. You just need to be careful of the last digit, right? Okay then. Anyone else have any questions? Raise your hand. So if this is a 4-digit palindrome, 1, 2, 3, 4. If I give you 4-digit palindrome, okay, from number 1000 to 9999. Everybody, you go and think how many options you have. Can you go and multiply together? And can you give me your answer, please? How many palindromes do I have from 1000 to 9999? Can everybody calculate it and type it? Type your answer in the chat, please. Zhe Yu, got it ready. Actually, you know what? A lot of people got 900. Students, again, be very careful. You have 9 options here. You have 10 options here. This digit must be the same as the second digit. Yes or no? What about this? Must be the same as the first digit. Yes or no? So how? The answer is 90 again. Not 900. 90. Understand? Okay, be careful. Students, be careful. Now let's look at the next one. Okay, over here, I'm going to introduce to you something. I'm going to introduce to you a square minus b square equals to a plus b, a minus b. Let me show you an example. 5 times 5, which is 5 square, 5 times 5, minus 4 times 4, which is 4 square, equals to this plus this minus this. A square minus b square equals to a plus b, a minus b. Let us work it out and see if it is correct. 5 square, 5 times 5, 25. 4 times 4, 16. Equal to 5 plus 4, 5 minus 4. Correct or not, students? 25 minus 16 is 9. 9 times 1 is 9. Correct, right? So can you see why this is correct? Okay? So whenever you see two numbers like that, then you can just 5 plus 4, 5 minus 4. A plus B times A minus B. Okay? So let's make use of this to solve the question. I'm going to take this minus this. Then I'm going to take this minus this. Why is it minus? Why is it minus? Because this whole thing is minus. It's all minus. Don't get tricked by the plus. You are minusing everything in there. You are minusing everything in the bracket. You are minusing everything in the bracket, okay? So I take this minus this. This minus this. All the way until this minus this. Okay? So we have actually paired them up. We pair them up. Then what about the numbers at the bottom? Students, I give you 1 minute. Can you please add up the denominator? Add everything up. Tell me the answer now. I give you 1 minute. Use your rainbow method. Go and add everything at the bottom. What is the answer? Type your answer in the chat. Okay, come, let's take a look at the numbers at the bottom. Can we just do like that first? Until 8, 9, 10. Can you just do this first? What do you get? What is this plus this, Joel?
11.
What is this plus this?
11.
What is this plus this?
11.
How many 11s do you think you'll get here?
5.
Yes, 5 pairs. So what's the answer? 5 pairs?
5. 55.
Yes, correct. So you already know 1 to 10 is 55, right? Then what about 1 to 9? Do you think it's still going to be 55?
No.
Why? Because you are missing.
The 10.
So what's the answer?
So 55 plus 55 then minus 10.
No need to plus anything. You are missing a 10, right?
Yeah.
So why not you just take away a 10? What's the answer?
100.
No, as in like, what's the answer here?
Oh. Um.
Like you just take away the 10, right? I mean, what's the difference? You tell me what's the difference. You just take away the 10, right?
Yeah.
What is your total? If okay, let's say it's 1 plus 2 plus 3 until 10. The answer is 55. Yes or no?
Yeah.
Now I want to get rid of the 10. What must I do to the 55?
55 minus 10.
So what's the answer?
45.
Very good. So then what's the answer for the entire bottom?
45 plus 55.
Yes, and that gives you
100.
good job. Okay, thank you, Joel. Well done. So students, the bottom will be 100. So let's write 100. Okay, moving on. Remember we learned about this? So if I have a square minus b square, what can I do? A square minus b square equals to a plus b, a minus b, okay? A plus b, a minus b. All the way until the end, a plus b, a minus b. Now, you realize something, students. This is 1. 4 minus 3 is 1. This one is also 1. Everything will become 1. What is 1 times 2 plus 1? 1 times 2 plus 1 equals to 2 plus 1. 1 times 2 plus 1 is just 2 plus 1. What is 1 multiplied by 4 plus 3? It's just 4 plus 3. All the way until the end, what is 1 multiplied by 99 plus 100? Then 99 plus 100. Correct or not, students? I tell you what, I give you 1 minute. Give me the final answer for this question. Type your answer in the chat. 1 minute. Ariel, 1 plus 2 plus 3 all the way until 98, 99, 100. Ariel, what is this plus this?
101.
What is this plus this?
101.
What is this plus this?
101.
How many numbers are there all together here? From 1 until 100. How many numbers? How many numbers are there? 100 number. I'm pairing them up. You pair them up. How many pairs do you think I'll get?
50.
50. Very good. So that means I will get 50 pairs of 101. Yes or no?
Yes.
Then that will give me 5,050. Very good. So now we already know that we have 5,050 on top. 5,050. Divide by 100. Do you know how to divide? Okay, I teach you, okay? Okay, I teach you. Every number has a decimal. Now, anything after the decimal, if it is a 0, it does not matter. Usually we don't write decimal. If it is a whole number, usually we don't write a decimal place. But if you want to divide by 100, let me ask you something. How many zeros do you have here? How many zeros are there in the 100?
2.
2 0. If you divide by something that have 2 0, you need to move the decimal place 1 2. So your answer will be, the decimal place will be here. Then the rest is still 0 0 0. Okay, so the rest is the rest of the zeros actually doesn't matter. You just need to move the decimal place 2 times. So your answer will be 50.50. Now, let me do another one. If I divide by 1,000, then the decimal is here. How many times must you move the decimal?
3 times.
1 2 3. Very good. So the answer will be like that. Understand, Ariel? Well done. So students, this is how you divide by decimals. Count the 0. You count how many 0, then you just move the decimal. 50.50. Well done, students. All right. Anyone have questions about this? Raise your hand. Yes, Kate, question. Oh, no question?
I put 50.5 in the chat.
Well done, Kate. 50.5. That works. You are correct. Well done, Kate. So, students, what did we learn here? We learned that whenever you see a square minus b square, you can just change it to a plus b, a minus b. Then can you see everything become number 1? So many 1, 1, 1, 1, 1. So you don't need to care about the number 1, right? Then it becomes so much easier. Let's take a look at this now. Okay, for this, we need to find the units digit. I'm going to draw a table so that you can help us to spot a pattern. Let's try to spot pattern. Power and the units digit. Okay. Let's start for the number 3 first. Okay, I'll explain to you what I mean later on, okay? Let me just duplicate first. Now, can I ask Atharva? Okay, what's the meaning of units digit, Atharva?
The ones digit.
The ones digit, very good. Now, let's do a small experiment. What is the meaning of power of 2?
It means 123 times 123.
Yes. What is the meaning of power of 3?
123 times 123 times 123.
Yes, correct. Okay.
It's multiplied by itself, by the number of times, like, so it shows 123 to the power 2, meaning you just multiply the number 2 times.
Very good. You are correct. So, I want to observe the units digit. Do I need to, okay,
You don't have to do the whole thing, just do the ones digit of both multiply the ones digit of both the numbers. So
Very,
3 times 3, 9.
very good. So let me just do the whole thing so that I will show everybody how we are wasting time. Okay, I just want to prove something. Okay, 3 times 3 is 9, 2 times 3 is 6, 1 times 3 is 3, then 3 times 2 is 6, 2 times 3 times 2 is 6, 2 times 2 is 4, 1 times 2 is 2, then 3 times 1 is 3, 2 times okay. So then the answer is like that. The answer is like that. 15129. Students, even if you do the whole thing, even if you multiply the whole thing and you waste all your time, the ones digit is still the same what, right now, students? So do I need to go and bother to do everything? No.
Nope.
Okay, just multiply this and this. Straight away, you get the number 9. Nobody cares what is the answer here. Nobody cares. We only care about the last digit. Very good, Atava. So let's write it down. The last digit is 9. Okay, very good. Now, if I do this again. 1, 2, 3 times 1, 2, 3 times 1, 2, 3.
Then you just do 3 to the power 3. 3 times 3 times 3, 27.
No need.
No?
You don't even
Oh,
need to, you don't even need to do 3 times 3 times 3. Don't need. You know why?
why?
You already know that this one have a last digit is 9, right?
Oh, yeah. Then just do 9 times 3.
Yes, you just take 9 times the 3. Then
7.
yes, 27. So easy. So you don't need to keep on doing the whole thing. Okay,
So
very
you just find the pattern, right? You have to find a pattern.
correct. So now I'm going to use a table. So now my first question to you is this. You look at this number 13. Huh? Not
You
13
see
times 13.
13 times 13 times 13, 247 times.
So many times. Now my first question to you is this. Do I really need to take 13 times 13? Or
No need.
what is enough? It is enough to take what?
3 times 3.
Correct. You don't need to.
Then you spot the pattern. So suppose you do 13 to the power 2. Your unit digit will be 9. Then if you do to the power 3, your unit digit is 7.
Very.
Then if you do to the power 4, you get
Okay, so let's write it down, Ken.
okay.
Okay, we don't need to care about 13. That's why I write 3. I'm not going to write 13. I don't care about 13. I just look at the
Yeah.
last. So power 1, power 2, power 3, power 4, power 5. So you get 13 to the power 1, 3 to the power 1, 3 to the power of 2, 3 to the power of 3. Then you times 3 again. You keep on times 3. Keep on times 3. What do you get?
1,
Then you times 3 again.
3.
Then you
Then
times
you already have the pattern then.
yeah.
It's 3971. 3971.
Very good, Atava.
Now you do 247 times the number you have in one set. In one set you have 4 numbers. So 247 divided by 4. Am I correct?
Yes, you are correct. So we realize that the number keep on repeating every 4 times. So you want to find out 247. How many times does it repeat? You get a remainder of 3.
Yes. So you looked at the third number in the set, which is 7. Unit digit 7.
So the digit is 7. Well done. Good job, Atava. You did it. Okay, I think you know what you're doing. So students, no, please take note. The question, the pattern keeps on repeating. So if the question keeps on, the pattern keeps on repeating, you just need to divide it by 4. You find out what's the remainder. For example, 1 divided by 4. The remainder is 1. So can you see this remainder is 1? 2 divided by 4. 3 divided by 4. 4 divided by 4. 5 divided by 4. Every time the remainder is 1, the unit digit is 3. Every time the remainder is 2, the unit digit is 9. So if I have a remainder 3, then my unit digit must be 7. Now I'm going to ask Reagan. Reagan, let's look at the next one. Do I really need to care about the number 17?
No.
Which number should I care about? Which number is enough?
1,
7, correct. So let's just care about the number 7.
7,
Power 1, power 2, power 3, power 4, power 5. 7 to the power of 1 equals to,
7,
then you times 7 again. 7 times 7 is 49, right?
49.
Should I write 49?
No,
What should I write?
you're right. Only 9.
Yes, you only care about the last digit. Then you times 7 again. 60 what? 7 times 9 is 60 what?
3,
So what number should I write?
3,
Yeah, then you
3,
times 7 again.
21, 1,
Very good. Then you times 7 again.
7.
Does the number
Oh, no. Yeah, 7.
does the number start to repeat itself?
Yeah.
Yes. So you keep on repeating every 4 times. So now let's look at the power here. 379. So if you take 379 divide by 4, we get a remainder of 3. So can you tell me what is the unit digit? What is the unit digit? The remainder is 3, Reagan. Whenever the remainder is 1, the unit digit is 7. Whenever the remainder is 2, the unit digit is 9. So whenever the remainder is 3, what is the unit digit?
3.
Yes. So we got the unit digit of 3 here. Now let's move on to the last one, Reagan. 4 to the power of 20,
Okay.
22. So let's look at the number 4. Power 1, power 2, power 3, power 4, power 5. 4 to the power of 1 is?
4,
Then you times 4 again.
6, 6,
Times 4 again.
4,
Times 4.
6,
Again.
4,
Ah, very good. What do you notice? 4 to the power of an odd number equals to what is the unit digit?
6,
Odd number, power, odd power, odd.
4,
What about to the power of an even power?
6,
Correct. This is even, even. Even power give you 6. Correct or not? Then the
Yeah.
the odd number give you 4. So now you take 4 to the power of 2022. Is this even or odd?
even,
So what answer should you get?
6,
Good. So now you have 6 here, 3 here, and 7 here. Okay, that means the last digit is 6 here. 7 here, 3 here, 6 here. So if you add all them together, add all of them together, what will be the unit digit? What will be the unit digit?
16,
Units digit.
6.
Good. Well done, Reagan. Any questions about this?
Nope.
All right. How about the rest of you? Everyone know how to spot pattern now? Huh? You don't need to care about the whole number. Just take the last digit. Don't need to multiply it, the entire number. Okay? Just look at the last digit. Enough. Save your time. Save your effort. Okay? All right. Students, look at question 10. I will give you 30 seconds. In 30 seconds, if you cannot answer it, that means you already don't know. Okay, 30 seconds. 1, 2, 3. Type your answer in the chat. Time's up. Why did I only give you 30 seconds? Because for this question, you either know or you don't know. There's no working required. Students, if you don't know, right, let me introduce you to cyclic number. What is a cyclic number, students? This one you must memorize. If you memorize it, then it's so much faster. Everybody, I want you to memorize this number. Are you ready? 142,857. What makes this number so special? If you multiply by 1, of course, you will just get this. But if you multiply by 2, you'll get this. Multiply by 3, you'll get this. Multiply by 4, you'll get this. Multiply by 5, you'll get this. Multiply by 6, you'll get this. Multiply by 7, cannot. You stop here. Okay, you stop here. Do you notice that the numbers keep on repeating themselves? You notice, right? 142,857. 142,857. 142,857. 142,857. 142,857. 142,857. Can you see that it keep on repeating in a cycle? And that is why we call it cyclic number. If you multiply by 7, it will not work. Are you ready? Okay, let's see. 142,857 multiply by 7. It will not work anymore. The numbers all change already. Okay, so the maximum is 6. So for 6-digit cyclic number, you can only multiply by 6. There are other cyclic numbers which are bigger, but we don't need to know that. We don't need to know that yet. Okay, students? So the answer is just 142,857. Okay, because when you take this, you times 4, then you get 142,857. Understand? It keeps on repeating itself. It is a cycle. It's either you know or you don't know. Don't need to waste time working it out. Yes, Joel?
But is there other answers that has the same
No, no other answer. 142,857 is a very, very unique number.
Oh,
Yeah. So you must memorize this number, Joel?
okay.
Yes. Okay, so next time you see A, B, C, D, E, F, then suddenly E, F, A, B, C, D, then you start to think, oh, it must be a cyclic number. Okay, let's move on to question 11. Now, you have Rico and Alice walking at 6 a.m. And there's a road 14 kilometers long. So they are walking towards each other, okay? Rico and Alice. Now, they are telling you that the speed of Rico is 2 kilometers per hour. The speed of Alice is 5 kilometers per hour. So can I ask Kate? In 1 hour, Kate, in 1 hour, Can you tell me what is the distance that Rico can walk?
2 kilometers.
Yes.
Total is 7.
What about Alice? Ah, yes. So total they walk 7 kilometer in 1 hour.
So it's 2 hours because 14 divided by 2.
Correct. So if you want to walk 14 kilometer, you will take 2 hours. Very good. So what time did they meet?
8 a.m.
Well done, kid. So easy, this one.
Yeah.
Anyone have questions about this? Okay. You just need to know what is the meaning of kilometers per hour. What does it mean? That means in 1 hour, I am able to walk 2 kilometers. Understand? That means Rico can walk 2 kilometers in 1 hour. Alice can walk 5 kilometers in 1 hour. So total, they are going to walk 7 kilometers in 1 hour. So in 2 hours, they will be walking 14 kilometers and finally meet. Okay? Let's take a look at this one. Okay, this is a little bit more challenging. Okay, tell you what, I'll give you all 2 minutes. Can you all think about it? And if you have an answer, can you share your answer? Good. Now, my first question to you, Kevin, is in 1 second, right? Can you tell me, okay, because they told you that Judith takes 40 seconds to complete 1 round of a track, yes or no? So if I give her only 1 second, can you tell me what fraction of
One
the...
of 40. One of.
Yes, very good. She can only run 1 out of 40 in 1 second. Then 2 seconds, 3 seconds, 4 seconds, until she finish in 40 seconds, right? What about the other person, Kira? Kira takes X seconds. So can you tell me in 1 second, what fraction does Kira run? One out of what? 1 out of what? Never mind lah. You imagine that X is a number 25 lah. Or
Yeah.
you imagine that X is number 100. I don't care what number it is lah.
Okay.
If let's say it's 100, then what fraction can she complete?
1 of 100.
If I use a number, you suddenly can tell me the answer. The moment I change it into a letter X, you suddenly don't know how to answer. Can you change the number 100 back into a letter X? Tell me what fraction does she travel?
25.
1 over what?
1 over 25.
1 over X.
Over X.
X is a number.
Oh.
It's just that you don't know what number it is, but it's still a number. Okay?
This is
So
not.
it's 1 over X. Okay? So that is what we have gotten so far. Now, next. Okay, they already told you that they pass by each other. Okay, this is the circle, right? They will pass by each other every 15 seconds. So do you agree with me if I say that both of them together, both of them can run 1 circle in 15 seconds? You agree or not?
No.
Why not? Because they pass by each other every 15 seconds.
Doesn't mean they just.
Every 15 seconds they pass by each other, yes or no?
Yeah.
If they want to pass by each other, then Judy must run until here. Then Kira must run until here. Then they will pass by each other here. Yes or no?
Yeah.
Then can I say that total, you add them together, Judith plus Kira, they can run 1 circle in 15 seconds. Yes or no?
Yes.
Yes. Correct. Atava, you raise your hand. Yes, Atava.
Did they start at the same starting point?
Yes.
Okay.
Okay. But Atava, even if they did not start at the same starting point, it does not matter because they say every 15 seconds. Okay, so let's say they did not start at the same place. Let's say this guy started here and this guy started here. Okay, fine. The first time that they pass each other, it may not be 15 seconds. Fine, that's okay. But the second time that they pass, it will already be 15 seconds. From this time onwards, every time is 15 seconds, 15 seconds, 15 seconds. So it does not matter whether they start from the same point or they start from a different point. So now, okay, Kevin, you have just agreed with me. You have just agreed with me that Judith and Kira, both of them together, takes 15 seconds. Takes 15 seconds to run one circle. Yes?
Yes.
So if I give them 1 second, 1 second, what fraction of the circle will both of them run?
1 out of 15.
1 out of 15. Correct. Very good. So let me delete this. I'm going to say that Judith plus Kira in 1 second will give you 1 out of 15. Agree?
Yeah.
Definitely. Okay. So now all you need to do is we need to solve the problem. How should I solve the problem? Let's just combine the fraction, same denominator. Then we get this. I think we simplify the fraction a little bit lah. Let's multiply by 8 on both sides. Okay. Sorry. Let's multiply by 5 on both sides. Just to make it smaller a little bit. This become 8. Then divide by 5, divide by 5. Okay, now it's at least a little bit smaller. Then what is the LCM of 8 and 3? What is the LCM of 8 and... Actually, you know what? Let's not complicate things. Can you tell me what's the lowest common multiple of 40 and 15? Do you know, Kevin? LCM. Do you know the LCM, lowest common multiple, 40 and 15? 120.
190.
Okay, you times 120 on both sides. You divide by 40, you get 1. Divide by 40, you get 3. Divide by 15, you get 1. Divide by 15, you get 8. So now what do I have? 3 times this. Can you tell me what's 3 times x?
120 plus x.
3 times x. What is 3 times x?
The x is 3x.
3x. 3 times 40.
190.
8 times 1. 8 times 1 is 8 lah. Don't forget the... Sorry. This is being... I'm being careless. I am being very careless. Instead of multiplying by 120, you should multiply by 120x. So now I divide by 40x. Divide by 40x. Divide by 15. Divide by 15. Don't forget there's a 8x, huh? 8x, okay? So now we have 3x plus 120 equals to 8x. Not 8. 8x, because there's an extra x. I move this over to the other side. Positive become what?
Negative.
Become negative. So what is 8x minus 3x?
5x.
So x equals to how much?
X equals to 120 divided by 5.
And the answer is?
Equals to 24.
Yes, well done. The answer is 24. So, Kevin, you have any questions about this?
Nope.
All right. Remember, some of you guessed 25, 27. I say quite close. Right? Yeah, you are correct, students. 24 is the answer. Anyone have questions? Raise your hand. Yes, Zachary, you got 24 just now. I saw. But you
I
guessed,
got 24.
right?
Yeah.
So it's not counted, okay? Uh,
Uh,
unless it is a multiple choice, then go ahead, you'll get it. But for open-ended question, you need to show your working lah. Let's look at the problem, the challenging problem. Yes, Atava, you have a question?
This looks like the easiest question of this worksheet, but then it's kind of hard.
I'm glad you said it. Yes, Atava. Good observation. Students, this is such a short question. It sounds so easy, and it even involves cookies, right? It's like a very childish question, but guess what? It's not that easy, okay? There are 7 cookies. How many ways can you finish all the cookies if you must eat at least 1 cookie per day? Now, there's so many ways to do this, students. You can make a list lah. Oh, okay, maybe every day I eat 1. Every day I eat 1. Then I finish everything in 7 days. Or maybe I eat 2 on the first day. Then I eat 1 and 1 and 1 and 1 and 1 and 1. Or maybe I eat 2 and then I eat 2 and then I eat 1 and 1 and 1. Or maybe I want to eat 2 and 2 and 2 and 1 and 1 and 1. Or maybe I want to eat 2 and 3 and 2. Or maybe I want to eat 2 and 3 and 1 and 1. This is going to take forever lah. It's going to take forever. You can even eat like that. Or you want to eat like that. Or you want to eat like that. Or you want to eat, I don't know how you want to eat your cookie. But there can be so many ways to finish your 7 cookies. I give you 2 minutes. Think about it. How are you going to solve this challenging problem? If you have an answer, type it in the chat. I give you 2 minutes. So students, it looks like nobody can get the correct answer. Okay, that's why we call it challenging in the first place. Anyway, I have a very useful technique. Yes, Joel, you have a question? Oh, it's not 70. Yeah. Okay, I have a very useful technique that you all can use to solve this question, okay? Now, first, I'm going to draw some stars. Oops. Okay, I'm going to draw 7 stars, okay? Why do I want to draw 7 stars? Because we have 7 cookies. I would like everybody to pretend that these are your 7 cookies, okay, students? Now, I have drawn some stars. Now I'm going to draw some bars. If I draw a bar like this, what does it mean? It means that I ate 1 cookie and followed by 6 cookies. So I took 2 days to eat my cookies. 1 cookie on the first day, 6 cookies on the last day. Okay? Let me do another one. If I draw another bar here, what does it mean? It means that I ate 1 cookie on the first day, 3 cookies on the second day, 3 cookies on the last day. Do you notice that I finished all the 7 cookies? Right, students? Can I ask Jill, what does it mean if I draw my bar like this? If I draw my bars like this, okay, what does this mean? How did I finish my cookies?
That means that some days we ate 2 cookies, some days we ate 1.
On the first day, how many?
2,
Second day?
2,
Third day?
1,
Last day?
2.
Correct. Is it easy to understand, Jill? Is it easy to
Yes.
understand the drawing? Yes, right? Very good, Jill. You are correct. So students, as you can see, I'm using stars and bars to represent how I eat my cookie. This method is actually called the stars and bars technique. Okay? It's called the stars and bars technique. So, can I ask Zachary, what does it mean if I draw my bars like this?
That means
On the first day, what?
first day you ate 5, and then second day you ate 1, and then third day you ate 1.
Very good. Zachary, what does it? Zachary, am I allowed to draw my bar? Am I allowed to don't draw any bars?
Yes.
What does it mean if I don't draw any bars?
Eat 7 cookies in 1 day.
That means yes, I eat 7 cookies in 1 day. Correct. Zachary, correct. Am I allowed to draw my bar like this? Like this? What does it mean if I draw it like this?
4 cookies and day 1, and then 3 what?
No. Day 1, how many? Day 1, how many cookies?
0.
0. Day 2?
Day 2 4.
Day 3?
Day 3 3.
Yes, correct. Atava. Yes, you raise your hand.
I have an objection. They
What?
said if he were to eat at least 1 cookies per day. So on day 1, you cannot eat 0.
Very observant. Thank you, Atava. Well done. I was about to ask Zachary, are you allowed to do this? What's your answer, Zachary?
No.
Why not?
Because the question says so.
Yes, the question says you must eat at least 1 a day. So I'm not allowed to draw. I am not allowed to draw my bar here. Am I allowed to draw a bar here?
No.
No. Okay, because your cookies are all finished already. Number 1, because your cookies are all finished already. And number 2, you're not allowed to eat 0 cookies on any day. Okay? Very good, very good.
So your mom wants you to have cavities.
Sorry, say again.
So your mom wants you to have cavities because you have to at least have 1 cookie per day.
I don't think 7 cookies will give you cavities, okay? Maybe
Okay.
70 lah. 70, then you get cavities, okay? So, students, now you already know the star and bar method. I want you to imagine this. The maximum number of bars I can draw is like that. That means I'm eating 1 cookie every day lah. That's for 7 days, right? Now, I want you to pretend, students, every single bar has a mind of its own. Every single bar has a mind of its own. He can choose. Should I appear or should I disappear? For example, there are 6 bars, right? There are 6 bars, right? Let's say this guy, okay, let's call this A, B, C, D, E, F. Let's say person D is very lazy today. Then he said, I don't want to appear. I'm going to disappear. Oh, never mind. If he disappear, what does it mean? That means you eat 1 cookie, 1 cookie, 1 cookie, 2 cookie, 1 cookie, 1 cookie. Okay, let's say person B. Person B is very lazy. I don't feel like appearing today. I don't want to appear. Never mind. If you don't appear, it's fine. 1, 2, 2, 1, 1. Understand, students? Pretend that every single bar has a mind of its own. He can have 2 choices. First choice, I want to appear. Second choice, I don't want to appear. I'm lazy today. 2 choices, to be or not to be. Understand? So, students, to be or not to be. How many number of ways can he eat his cookies? The first bar have 2 choices, to appear or not to appear. The second bar have 2 choices, to be or not to be. The third bar have 2 choices, to be or not to be. Come on, tell me the answer. Continue. There are 6 bars altogether. Everybody type the final answer in the chat. Now, type it now. Do your calculation and type it now. Don't be careless, please. Please don't be careless. Multiply properly. How many 2s are there? How many bars are there? There are 6 bars. Very good, students. Okay. I see a lot of you getting the correct answer. That means you need to take 2 to the power of 6, right? So 2 times 2 times 2 is 8. Times 2 again is 16. Times 2 again is 32. Times 2 again is 64. Very good. Well done, students. Okay, so now that yes, Atava, you have a question?
How does this work?
What work?
Like, just doing 2 times 2 times 2. How can this work?
That means how can you find the number of waves?
Yeah,
Well, every bar have 2 choices, yes?
yeah.
So if the first bar say I don't, okay, let's simplify it. Let's simplify it. Let's just have 2 bars. How many? Okay, let's say you have 3 cookies. Let's
Okay.
make a list. Let's make a list. You can choose to eat 1, 1, 1, or you can choose to eat like that, or you can choose to eat like that, or you can just choose to eat like that, right?
You have 6 ways.
Why 6?
Wait, not 6, not 6.
How many ways?
4?
Yes. 4 ways. So how do you get 4 ways? You have 2 bars here. This guy and this guy. Person A and person B. You ask person A, do you want to appear today? Then he either say yes or he say no, right? Either he say yes or no. 2 choices. Let's look at person B. He can either say yes or no, yes or no. Then there's
Yes.
4 ways. You see, there's 4 ways, right?
So by our small experiment, it shows it works.
Yes, by the small experiment, it shows that it works. Very good, Atava. You're getting the hang of it. Well done.
Okay.
So students, can you see that this is not only shorter, right? Not only shorter, but very accurate. You don't need to waste all your time writing down all the ways. Correct, students? Isn't this much easier way to solve the question? Anyone have any questions about this? Raise your hand. Stars and bars. All right then. Well done. We have managed to complete today's worksheet. We have learned several new techniques, right? A square, B square, stars and bars. Yes, Kate, question?
For the last question just now,
Stars and bars.
for stars and bars, wouldn't it be easier to do circles and bars?
Yes, but you know what? Stars rhyme with bars. Yeah, it's actually quite if you Google it, if you Google stars and bars, you can find stars and bars. If you Google it, you can find some stars and bars techniques. Okay. So students, I hope you enjoyed the lesson today. I think the stars and bars were quite fun. We learned a lot of new techniques: a square, b square, stars and bars. We learned how to group numbers together, how to do the fractions. Remember? So please do your revision so that you will be able to apply the strategy for next time when you solve problems. All right? If you have any questions, please stay back and ask me. If not, I'll see you next week. Bye, everybody. Bye, Ariel, Ethan, Jill, Kate, Evelyn, Zhe.